Hello guys, welcome back. So today we are back with the day 4 of the JEE Advanced 100-day question series. So basically guys, I hope you have seen the question. So this will be the question for today. Okay. And this one is a question, good question, not purely on conics, calculus involved, but still. So I guess you can see it on the screen. And guys, let me tell you, this question is a really good question. Okay, like all the questions I'm trying so that all the questions which come in this series are 100% good, but still. So guys, if you want, you can try this question out because I think you should be able to solve this. Okay, like the questions in the day 1 and day 2 videos, they were a bit long, so I said that they might not come directly as a full question in your JEE Advanced, but this question you see on the screen right now, this can surely come. Okay, because although this one will go a bit lengthy, but this is allowed. Okay, I guess this is allowed as a difficult question. Anyways guys, you can try this question out. I will wait for a few seconds and then start on with the solving. Okay, so I hope guys we can start off now. So basically if we give a short reading to this question, let p y square equals to 4 beta x, this is a parabola, you can understand, and s a x square minus 2h xy minus by square equal to 0, where h square minus ab is given greater than 0. Okay, this will be a very actually important thing later on. Is a pair of straight lines. Like you can understand, this equation represents a pair of straight lines and the angle between these lines is theta. So if the total area enclosed in between P and S can be represented as A is equal to 32H divided by 3A cube cos square theta, which and times of this thing, then the value of 1 plus 5 by root 2 beta is equal to. Okay. So guys, first thing is that like you can see that the area enclosed between P and S. Now S is a pair of straight lines and we obviously can't find out the area in between a parabola and a pair of straight lines. We can between a parabola and a single straight line. Okay. So first target would be to find out something from this. Maybe we can find out two straight lines from this. Okay. That would be our first target. So for that, actually I am starting off now. Basically, first thing that I will do is I will write off our equation, which is ax square minus of 2hxy minus by square equals to 0. And now what I am going to do is I will divide this complete equation with x square. Okay. So this equation will become a minus of 2h times y by x minus b times of y by x whole squared is equal to 0. So actually not if, we know that m is y by x some sort of, because it is the difference of y by x, but still, like see, the thing that I'm trying to do is I am trying to construct a quadratic from here whose roots are the slopes of the two straight lines. Okay. So it's actually in that form because m is equal to y by x. So I can write this as like a little bit of sign change also. If we multiply this particular equation with minus and substitute m for y by x, then we will actually get bm square plus 2hm minus a is equal to 0. Okay. So actually guys, this particular equation will have the solutions as m1 and m2. Okay. So guys, what I am now going to do is, like if we can easily find out the roots of this using our quadratic formula. So m will be equal to minus b plus minus root. Okay, I actually missed one thing. It's minus 2h plus minus root b square minus 4ac, that will give us 4h square plus 4ab, and this thing is whole divided by your 2b. So you will see a 2 is getting cancelled from everywhere. So these roots come out to be minus h plus minus root under of h square plus ab, and I guess are divided by b. So these will be our m1 and m2. Okay, so I will change the page, guys, because I have no more space here. So right, our roots have come out to be m1 is equals to minus h plus root under h square plus ab whole divided by b. Like guys, I sometimes write b like this and sometimes like this. They are both same. Okay, please note that. M2 is equal to minus h minus of root under h square minus ab whole divided by b. And now actually if you see one thing, why I said that our expression, I will show it to you. So basically the reason that I said that this thing is very important is because as h square minus ab is greater than 0 and abh, all of these belong to real positive part, like all of these are greater than 0, that would actually imply that this particular equation here has its discriminant greater than 0. Okay, and because b is positive, so from there if you see, one is minus h plus and another is minus h minus. So from there actually we can say that our roots will have opposite signs. One root will be greater than 0 and another root will be less than 0. Okay, I hope this was simple logic. Okay, so guys, I will return back. Okay, one more thing, like I should have mentioned this, I will mention once again. Basically here, like h square minus ab greater than 0 actually means h square is greater than ab. Okay, now because a, b, h are all positive, so ab product is positive and h square product is also positive. Now if you ask about the discriminant of this particular equation, it is actually delta equal to h square plus ab. Okay, so that is also greater than 0. That's why from there actually we can infer this. Okay, I should have written this before. Please note that down. So I am now returning to the question. Okay, so guys, actually we have our two slopes ready. So for the time being, let's do one thing. Let's consider that the line is y equals to mix and y square equals to 4 beta x. Now the reason why I chose mix is because if you see our pair of equations, the combined form, the combined quadratic in a function of x comma y, the pair of equations the pair of straight lines equation we had, that actually has no constant term. Okay, it has x square, y square and an xy term. If it had a constant term, it would have been a problematic situation, but it doesn't have any constant term. That is why I cannot put a constant here. Like, not cannot, I don't have to put a constant here. Okay, so if we actually want to calculate the area in between these two, like one thing you can understand, they will intersect. One point is at x equal to 0, but the other point we need to find. So for that we will solve these two. So if I try to solve these two, I guess it's pretty easy. Mix square, putting this into this, will be equal to 4 beta x. So from here actually we get x equal to 0, one equation, and another equation I guess will be x equal to 4 beta by mi square. Not equation, these are the two solutions. Okay, so one point is 0 comma 0 and another point is basically 4 beta by mi square comma 4 beta by mi. Okay, so guys, if we actually want to write area in between y equal to mix and y square equals to 4 beta x, let's denote this for the time being as ai. So our ai will actually come out to be integral of 0 to 4 beta by mi square. And if I'll do a little bit of graphing here in the side, like this is actually pretty obvious I guess, but still I will do a little bit of graphing. If we draw the graph for this thing, and actually y square equal to 4 beta x will be something like this. Like, wait, this is y square equal to 4 beta x, and obviously the straight line will be passing something like this. Okay, this is a very standard situation. Like the sum is difficult, but the situation that is given here is actually asked in JEE mains also. Okay, this is nothing very unknown. The sum is difficult, that's for sure. And here this point is actually your 4 beta by mix, not mix, sorry, mi square, and this is 0. So it's upper curve minus lower curve, so I guess parabola minus straight line. So this thing will come out to be root under 4 beta x, and if you want me to shade the area required, like this is for one straight line, okay, we will like see what the second straight line actually comes out to be. This part is actually for one straight line. This is your area, okay, shaded in red color. So this will be root 4 beta x minus mix dx. Okay, now guys, actually one thing, if you observe our m1 and m2 right here, I will move this. If you see our m1 and m2 right here, one thing that you can easily understand is m1 and m2 are actually equal in modulus but opposite in sign. Okay, like mod m1 is equal to mod m2, but your, okay, wait just a minute. Okay, wait. Actually, I said a wrong statement. It's not modulus plus. Basically, the thing is, if you see m1 and m2, the slopes are symmetric. Okay, it's minus h plus minus root under this thing will be actually h square plus ab. Correct this. H square plus ab. So actually, these two roots are symmetric in nature if you see carefully. Okay, so the thing that is actually going to happen, whatever area I find out for m1, the same area will be bounded for m2 as well. Like as per I think, if we want to denote in this particular diagram, it will come out to be something like this. It's not perfectly passing through the origin, and if you see this particular area actually that I'm also shading in red color, this particular area, okay, and I guess, it's my guess, I think that these two actually will be equal. Yeah, they will actually be equal. If you solve, you will see that they are also equal. Like this coordinate, x coordinate is same. Okay, so actually these two areas are same. If we take this as a1 and take this as a2, then from here a1 is equal to a2. Like that's the advantage. Like see, if we didn't have our second degree equation given in form of proper straight lines passing through the origin as given here, if it had some constant, then this problem would have become like 10 times much more as complicated. Okay, but that's not the case. We have them in symmetry and they are both passing through the origin, so that's why actually little bit of advantage you get. Otherwise it would have become more difficult. Okay, like if you want, you can try solving that also. You can frame a question by yourself, punching into this and try to solve that also, because JEE Advanced is totally unpredictable. I believe that. Okay, so if we see a1 is your integral 0 to 4 beta by m1 square. Like we only have to calculate one integral. Okay, if we calculate a1, a2 will be the same. Like with respect to sign, maybe opposite down the x-axis, but area is always positive. So we will just multiply this with 2 and we will get our value. And this is your m1x dx. Okay, so let's solve this integral quickly and see what is coming. Okay, so guys, this will actually come out to be, I'm writing like 0 is not needed, right? Okay, then it's easy. This will actually become 4 root beta and whole divided by 3, and inside the bracket you will have 4 beta by m1 square times 3 by 2. I hope you can understand because it's integrated, and this will be minus m1 by 2 and 4 beta by m1 square whole square. Okay, so this thing approximately becomes 32 beta square whole divided by 3 m1 cube minus of 8 beta square whole divided by m1 cube. So this will come out to be 8 beta square divided by 3 m1 cube. Okay, and this is also equal to, you can say, modulus a2. So basically if we want to find out the total area, okay, wait, it's not modulus a2 actually. Okay, one thing, like a1 and a2 will not be exactly equal because it's m, so I just got puzzled. Actually they are not equal. A2, when we put a mod, just put mod on both the areas, okay, because we don't know which one is which. 8 beta square, this will be 8 beta square by 3 m2 cube. Okay, they are not exactly equal. So if you see total area, this total area will actually become mod of A1 plus mod of A2. So this thing will become 8 beta square by 3 m1 cube plus of 8 beta square by 3 m2 cube. Okay. So guys, actually after this there is a whole lot of calculation present, because if you see our m1 and m2 which we found in the beginning, we have to punch them into this equation. Okay, so that seems a bit scary because it looks like a whole lot of calculation. Yeah, there is calculation, but I have tried to simplify it as much as possible. Okay, like we will not go into solving too much. I have tried to reduce the number of steps as much as I could. So let's do that quickly. Okay, so if we actually, I am taking this here. So if we actually take out common 8 beta square by 3, what we will get inside the bracket is b whole divided by minus h plus root h square plus a b whole cube, and this is plus of b whole divided by h plus root h square plus ab whole cube. Okay. So guys, for the time being, I am doing one thing, because this root h square plus ab expression is actually that is causing a lot of problem. So what I am doing is I am substituting k as root h square plus ab. So actually from here your m1 will become equals to minus h plus k by b, and m2 will become equal to minus h minus k by b. Okay. So now if we add, like if we want to try to calculate 1 by m1 cube plus 1 by m2 cube a little separately, then this thing will come out to be equal to small b cube whole divided by k minus h whole cube plus of small b cube whole divided by, I guess this will come out to be k plus h whole cube. Okay, and I guess one minus also. Wait. Okay, yes, there is one minus also here. Okay. So guys, actually this thing is little bit easy to calculate. So if you calculate this, maybe I can calculate this. Okay, wait, I will calculate this and tell what is coming. Okay guys, this is actually coming out to be 2k times of k square plus 3h square, and this thing is actually whole divided by k minus h into k plus h whole cubed. Okay. Okay, and actually there would be one b cube also here. Okay, I missed that. So guys, from here actually this expression will be shortened. Why? Because if you see, we had done a small substitution here. So if we square this up, then actually we would be getting something, and that is k square minus h square is equal to ab. So if we cube both sides, a cube is coming to be equal to k square minus h square by b cube. Okay. Like this question, if you ask me why this is so similar, then my reply would be that this question is very similar to there was one tangent question with the same amount of calculation that came this year in JEE Advanced. Okay. And like this question and that question don't match in the content, but whatever topics are used, they exactly match if you see carefully. Okay, so that's why this is very relevant. And this amount of calculation, like maybe I can't mercy on this amount of calculation, because this is minimum. Okay, bare minimum. Anyways guys, let's proceed. Okay, I just noticed one thing. I had given a plus here, so this will be actually minus. Okay, because minus h minus root under h square plus ab. So basically one minus is coming out from here and this is becoming minus. Okay, please correct that. Okay. So our final expression for this thing actually comes out to be 2k times k square plus 3h square whole divided by a cube. Okay. So don't worry, calculation is not still over. Okay, a lot to go. So area comes out to be 8 beta square by 3 times of 2k into k square plus 3h square whole divided by a cubed. So if we little bit calculate this thing, like merge everything into one, then this will come out to be 16 beta square k times of k square plus 3h square whole divided by 3a cube. Okay. Okay guys, so basically this is actually the end of the first part of the question. Now one thing is that we have been given, like we have found out the area from here officially, but thing is that they have given our area equation, basically the equation they wanted, they have given it in terms of the angle in between the two lines. Okay, so what I thought about was if we could find out another area like area under the curves, these two curves result in terms of the thetas and sines and convert them somehow into a, k, beta and h, then maybe we can compare them, because this area that we found out here and that area would be exactly same, right? So if we compare them, maybe we can get our answer. That's the idea. So let's try to do that quickly. Okay, to do that, actually we know something, that our angle between two pair of, like not two pair, I should say pair of straight lines, tan theta, it is actually modulus of 2 root under h square minus ab whole divided by b minus a. So now this particular thing will be positive, and so it will open with a plus. Okay, not h square minus, I'm sorry, plus ab. So this thing will open with a plus. Two reasons. First reason is that your h square plus ab is greater than 0, and a much stronger reason than that is theta is less than pi by 2. Okay. Okay. So guys, actually if we try to find out sine theta and cosine theta from here, then sine theta will become 2 root under, like this is perpendicular by hypotenuse, right? Sine theta, and this is perpendicular, so this thing will actually become same. And if you calculate the perpendicular by base, so if you calculate the hypotenuse by adding these two, so this will directly come out to be root under of a minus b whole square plus of 4 times h square plus ab. Similarly, your cosine theta would be equal to b minus a whole divided by root under of a minus b whole square plus of 4 times h square plus ab. Okay. Okay. Now, okay, guys, one thing, just do this. Put mod b minus a for the time being inside a bracket. Okay. Because we are actually not sure, although we know both are positive, but we are not sure whether a is greater than b or b is greater than a. Okay. So comfortable to put it inside a bracket, I guess. Okay. So guys, if we now actually put it into the area equation that was given to us, I will write it down. So this was the area equation that they had given to us. So now if we put in the values of the sine theta and cos theta that we found out here, then this thing will be 3a cube times cosine square theta, and little bit of calculation inside this, but don't worry, we have to do it. Okay. So a minus b whole square times of sine squared theta, so this will be 4 times h square plus ab, and I guess this thing is squared, so a minus b whole square. Like, see, the only good thing about this whole calculation is that in both the fractions we will get right now, you will have the denominator same. So basically that will make the thing pretty easy. And you will see it's not actually that difficult. Okay, this will look very big, but a lot of terms will be common and it will be really simple. You will see. And this thing goes out to be minus ab, a minus b whole square, whole divided by a minus b whole square. And guys, one more thing, like I put your a mod b minus a, but actually if you see carefully in our expression right now, we don't need that mod because a minus b, wherever it is appearing, it is getting squared. Okay, so no worries about a minus b or b minus a's sign. Okay, so let's evaluate this. So guys, if we again write this down, this will be 32h whole divided by 3a cube cosine square theta, and this thing is multiplied by, this will come out to be 4 times h square plus ab times of a minus b whole square minus ab times a minus b whole square, and this is whole divided by your a minus b whole square plus of 4 times h square plus ab. So guys, from here actually, if you see, a minus b whole square will be common from these two terms. Okay, so this will actually, if we again evaluate this, this will come out to be 32h by 3a cube cosine square theta, and this will come out to be a minus b whole square times of 4h square plus 3ab, and this is whole divided by a minus b whole square plus of 4 times h square plus ab. Now guys, one thing, like still something is left, we haven't put cosine square theta here. So if we put that, actually what will come out is 32h by 3a cube. This thing will be a minus b whole square. I'm writing it fully, okay? I will show you the cancellation that will occur. This will be 4h square plus 3ab, which is whole divided by a minus b whole square plus 4 times h square plus ab, and cosine square theta will be actually reciprocated, so this thing will become a minus b whole square plus of 4 times h square plus ab, which is whole divided by, I guess, a minus b whole square. So a lot of things are actually cancelling. This completely gets cancelled. A minus b whole square, a minus b whole square is completely cancelled. Okay, so we have actually got our final expression. So I will write it down. So from here our final expression for the area comes out to be 32h times of 4h square plus 3ab whole divided by 3a cube. Okay, so guys, if we, like, this is the area expression, the total area A, and we had got something, if you remember, a while ago also. So now if we equate both these, then what you will actually get is 16 beta square. I will write both the expressions and equate them. So 16 beta square times root h square plus ab times of your 4h square plus ab. This will come out to be equal, I mean, by 3a cube. I guess, yes, yeah. So this will come out to be equal to 32h by 4h square plus 3ab whole divided by, once again, 3a cube. Okay. So guys, some little bit of calculation, I mean cancellation. 3a cube, and 16 twos is 32, and I guess no more. So this finally comes out to be beta square times of root h square plus ab times of 4h square plus ab. This is equal to 2h times of 4h square plus 3ab. Okay. Okay. So guys, after actually this step, you will seem to arrive on a deadlock. Deadlock meaning, like, after solving this much, you will see that you finally now can't see anything else from here. I hope you can understand that. Like, I don't know if this is some sort of squaring and adding and if it is solvable further or not, but right at the moment I can't see anything that can solve this further. Okay. So basically guys, what I did was, because our a comma b comma h, they were all being given to real positive. So from there, okay, actually I considered one case where AB is tending to 0 plus. Now see, I will show you that in the question. Okay, so guys, actually the reason for the approximation we are going to do is this. This theta is given to be less than pi by 2. Okay, less than. And because A, B, H are all belonging to real numbers and theta is less than pi by 2, which means it is an acute angle. Okay. So if I because we have arrived at a scene where we are not very sure about what our M1 and M2 are. We know that they are opposite in sign. The factors we know are they are opposite in sign. They are 100% real factors. We know that h square plus ab is greater than 0, and we know that abh belong to real plus, I mean positive real. And one more thing we know, that the theta, the angle in between these two lines is acute. It is less than pi by 2, which means it's not equal to pi by 2. It is not exceeding pi by 2. So for that case, actually, because I couldn't, theta less than pi by 2 is given. So if this was not given, then I couldn't have done this approximation and this sum would have been a complete failure. But because theta is given less than pi by 2, so I am actually taking an approximation here, because see, this can be any case, right? Because they haven't specified that this will be nearly, like the lines will be at 20 degrees or 30 degrees or 60 degrees. We don't know anything. So it's an acute angled line. Basically for that, we can take any case to solve this. And because if you right now see, I will go to that page. If you right now see this thing, we have arrived at a complete deadlock. So what I am doing is I am taking AB tending to 0 plus. AB tending to 0 plus whenever I take in our expression of tan theta, which was equal to 2 times root under h square plus AB whole divided by modulus of B minus A. Now this particular thing actually becomes really negligible, but h square is positive, and with that when we add this thing, it's a large quantity whole divided by a small quantity. Okay, so tan theta here practically becomes a large value, but it is tending to infinity. It is not like theta will tend to pi by 2. It is not equal to pi by 2. Okay, and theta will tend to pi by 2 from the positive side. This thing is very important here. Like this last step we are going to do is really important, like much more than whatever calculation we did over there. Okay, because I think that that is the idea behind framing this question, because at the last when you arrive, you will get an idea about how the lines are from this equation. Because theta is tending to pi by 2 from the positive side, tan theta is tending to infinity plus. That's why actually the conditions are getting satisfied. It is an acute angle. So I guess AB tending to 0 plus, if we take, it will not only make our equation simpler, it will also satisfy the given condition. Because M1 and M2, if they satisfy all the conditions, if they satisfy whatever is given, then it's no harm to take M1 and M2 like this. Okay. So guys, if we actually take AB tending to 0 plus, then our equation will come out to be beta square root h square. This is an approximation equation. Okay, you can understand. Not an approximation equation, I would say, like an equation where AB tends to 0 plus. And this is 4h square. This comes to be equal to 2h times of 4h square. So guys, from here, actually 4 beta square h cube would come to be equal to 8 h cube. So we don't need h cube. So basically from here, beta square will be equal to 2. So we got our final answer. The beta we needed, it is equal to root 2. This is our, not the final answer, but the actual thing we needed. Okay. So if we now calculate 1 plus 5 by root 2 beta, and you will see, okay, like if you see the framing of the question, it very much matches this. Like 5 by root 2 beta. They wanted intentionally that the answer comes out to be a proper integer value. That is why they had given beta as root 2 and then framed this. Very logical. So this comes out to be 1 plus 5. And so our final answer for this particular question will come out to be 6. Okay. Okay. So Guys, this was like, I would say, the most intelligent area under the curves question I have seen in a while. The most intelligent. Like, this question is absolutely insane. Like, see, you can solve your normal area under the curves questions. The thing that came this year in JEE Advanced also, it was good, but it was, what do I say? It was sort of normal, like whatever you get, just some calculation. Calculation doesn't make things extraordinary, okay? What makes things extraordinary is things like this particular part. Like, this is crazy, okay? I am like mad respect for, I took it from an IIT Bombay sample paper, so you can understand the people who have framed this question, okay? Like, very much expected. The people who framed this question, I can't imagine what level to what level they might have thought at this point. Because even, like, I would be honest, when I arrived at this particular equation, I see it was seeming like I have done something wrong. I eventually checked my complete procedure that I solved. There was nothing wrong, okay? Nothing wrong. Not even a single calculation, a whisker. Whatever I wrote here, that is what I have calculated myself. And then this came to my mind that if we actually categorize this into something that satisfies our conditions, then it is nothing wrong. Okay. Anyways, so guys, this will be the end of this video. I would be back with the next day. So if you like my content, please do like, share and subscribe. And any doubts and anything else, you can feel free to ask me out in the comment section. So that's it for today, guys, and thanks for watching.